let's see how to find the derivative of inverse trigonometric functions. Question number 9, exercise 5.3 of your NCERT is find dy by dx if y is equal to sine inverse 2x upon 1 plus x square. Okay, so you know that we have done it already in your inverse trigonometric functions, how to solve these inverse trigonometric functions. Now look here carefully, it is sine inverse 2x upon 1 plus x square. And you know what I need to do is I need to get from here something of the form sine of something. Okay, sine of something. And x is needed to be substituted like this so that I can get sine of something from inside, so that I can just get a function which can be differentiated properly. Okay, so let us see what I'm going to do is, if you remember, you will find that if I put x as tan theta, okay, so it will be 2 tan theta upon 1 plus tan square theta, that is your sine 2 theta. Okay, so what I'm going to do here is put x is equal to tan theta. Okay, this thing implies theta is equal to tan inverse x. Now what does it become? It becomes that y is equal to sine inverse 2 tan theta upon 1 plus tan square theta. And you know, it is the formula for sine 2 theta. Now we know that the formula for sine 2 theta is, one formula is 2 tan theta upon 1 plus tan square theta. Okay, so it becomes sine inverse sine 2 theta, and from here, you know, I will just get as 2 theta. What is theta? Theta is 2 tan inverse x. Okay, so I got a simple inverse trigonometric function which can be differentiated easily. Okay, so I got y is equal to 2 tan inverse x. Now I have to differentiate. So differentiating with respect to x, what I will get is dy by dx is equal to 2 times d dx of tan inverse x. And you know what is the derivative of tan inverse x? That is 1 upon 1 plus x square. Okay, so it becomes 2 upon 1 plus x square, because d dx of tan inverse x is 1 upon 1 plus x square. Okay, so this is how simply I have just to solve it like we did it in inverse trigonometric functions, and then I will just reduce it to some proper inverse trigonometric function instead of the required proper substitution, and then I can differentiate the particular function obtained. Okay, so let us also see your 10 of your NCERT is find dy by dx if y is equal to tan inverse 3x minus x cube upon 1 minus 3x square, and x is lying between minus 1 by root 3 and 1 by root 3. Okay, so you need to differentiate. Okay, so how should I go? I'll go like, you know, I have to get tan of something from here. So what will I do? I will put x as tan theta. Okay, so theta will be tan inverse x. Differentiating need that I should just firstly solve it, okay, and then I'll differentiate it. So I'll put it y is equal to, this is still we have not differentiated, okay, we need for differentiation to represent it in some simpler form. So y is tan inverse 3 tan theta minus tan cube theta 3 tan square theta. You know, this is the formula for tan 3 theta. So it becomes 3 theta, and this is your 3 tan inverse x. Okay, 3 tan inverse x. Now I can now differentiate it. So differentiating with respect to x, dy by dx 3 into t dx of tan inverse x, which is equal to 3 into 1 upon 1 plus x square. 1 plus x square. Okay, now this is the derivative, okay, because we did the earlier question also in which we know that t dx of tan inverse x is 1 upon 1 plus x square. Now let us verify one condition is given here, that is your x is lying between minus 1 by root 3 to 1 by root 3. So let us see what does this means, how to check out this condition, why this condition is given here. Okay, so see what is given here. X is your tan theta. Okay, so this is just side by condition which we will be checking. Okay, now in this between I have to bring only theta. So what I need to do is I will operate by tan inverse. So it will be like tan inverse minus 1 by root 3. You know it becomes theta, and it is your tan inverse 1 by root 3. Now tan of minus theta is minus tan inverse 1 by root 3. This is theta and this is your tan inverse 1 by root 3. Now you know 1 is your tan 1 by root 3. Okay, you know it is at pi by 6. So it is at minus pi by 6 and it is at plus pi by 6. Okay, now my angle is here. I found my angle was, means I reduced it to this form. So my angle was 3 theta. So let us check 3 theta. 3 theta will be minus 3 into pi by 6 and 3 into pi by 6. So I get 3 theta is lying between minus pi by 2 to pi by 2. Okay, so is any condition for existence of this inverse trigonometric function violated? No, because all the conditions for domain and range are fully satisfied here. So this is okay. That means the derivative is there. Okay, so question number, let us see question number 11. Question number 11 is your y is equal to, find dy by dx for y is equal to cos inverse 1 minus x square upon 1 plus x square, and it is lying between 0 and 1. Okay, now here before differentiating, okay, you know it very well. It is very simple question. Again, you'll put x as say tan theta, and it will be 1 minus tan square theta upon 1 plus tan square theta, which will give you cos 2 theta. Okay, and this question will be done in that way. But first let's verify this condition. Okay, or we can start it from here also, but let's verify what, you know, from inside I'll get as cos 2 theta. Okay, so as I checked it for 3 theta, I'll need to check it for 2 theta. Okay, so for say simplicity, let's solve this side first. So put x is equal to tan theta. Theta is equal to tan inverse x. This thing implies y is equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta, and this is the formula for cos 2 theta. So I'll be getting it as 2 theta, which is your 2 tan inverse x, and the rest is I think same, differentiating with respect to x. I'll get it as dy by dx is equal to 2 into d dx of tan inverse x. So I think this is the repeated thing now. So d dx of dy by dx of, for this question we'll obtain it as 2 upon 1 plus x square. Okay, so this is I think simple. Let us verify this condition. Okay, x is lying between 0 and 1. Okay, what is my x? X is my tan theta. So again I just need to get theta. So what I will do, I will operate by tan inverse. So it will be tan inverse 0. This is theta and this is tan inverse 1. Tan 0 is 0. This is pi by 4. But my question is of 2 theta. So let us check whether it is holding properly or not. So 2 into 0 will be 0 and it will be pi by 2. So I think there is no problem in existing because cos is properly defined between 0 and pi by 2. Okay, so there is no problem in existence of this derivative. That's okay. Okay, so I think the question number 12, that is your sine inverse y is equal to, question number 12 is your y is equal to sine inverse 1 minus x square upon 1 plus x square. This can also be done properly. Okay, now here the thing is that in this question what you will get that apart from the side condition, one more thing you need to remember is when I will put say x as tan theta, what I'll get as sine inverse, it is 1 minus tan square theta 1 plus tan square theta. So it is your sine inverse, it will be not sine to theta, it will be cos to theta, but I need sine. Okay, so can I change? Yes, I can change. I will change it as sine 90 minus theta. Okay, I'll change it as sine 90 minus theta. Now I think it is very clear. So it becomes pi by 2 minus 2 theta. Okay, pi by 2 minus 2 theta. So I got y is equal to pi by 2 minus 2 theta. Okay, so what is your 2 theta is? Your theta was your again tan inverse x. Okay, theta is tan inverse x. So I'll put it like this and it will be 2 tan inverse x. So differentiating with respect to x, I get it as dy by dx is equal to derivative of, this is a constant, that is 0 minus 2 into 1 plus x square. So it becomes dy by dx is equal to minus 2 upon 1 plus x square. Okay, now what happens is that I just need to check the C side condition. So again 0 x 1. Okay, so x is your tan theta, same as it is in the previous question. Okay, so this thing implies theta is your tan inverse 0 tan inverse 1 theta, this is 0 and this is pi by 4. But here you are not having say only 2 theta. So let us check. It is 2 theta 0 and it is pi by 2. Now I need pi by 2 minus. So firstly I need minus 2 theta. Let's multiply with negative sign. Minus pi by 2. Okay. Is it true? Is it correct? No, it is not correct. Because you should remember that when we multiply with negative sign, the direction of inequality changes. So how will it behave? See. You need to multiply with minus 1. So what will happen? It will move like, it is wrong, okay? It is wrong. It will move like 0 greater than minus 2 theta greater than minus pi by 2. Okay? Now I need to get pi by 2 minus 2 theta. So that means I have to add pi by 2. So it will be pi by 2 minus 2 theta. Everywhere I'll get pi by 2. And it will be your pi by 2 minus pi by 2. So it turns out to be pi by 2. This is your pi by 2 minus 2 theta and this is 0. Now see, you just reverse it, means write it in proper manner and you will find again the same thing we obtained what we had in the previous question. Okay, this is how we make the conditions. This is the conditions need to be verified, that how the thing is existing. Remember this thing. Okay, when you are multiplying with negative sign, the direction of inequality changes. Okay, again what is happening for say question number 13. Your question number 13 is y is equal to cos inverse 2x upon 1 plus x square and the alongside condition is, okay, now see, I will just put again c as we did it for the first question. I'll put x as tan theta, theta as tan inverse x. Okay, now what happens is it becomes y is cos inverse 2 tan theta 1 plus tan square theta. and I'll get it as, remember, this is not the formula for cos. This is the formula for sine to theta. But I know that how to change sine to cos, because I need cos. So how will I change? Cos of 90 minus theta. So it becomes, I get it as 90 minus this. That is 90 minus 2 tan inverse x from here. So dy by dx is equal to, differentiating, pi by 2 will give me 0 and it will be minus 2 upon 1 plus x square. Okay, so it is not the case that you will directly get the substitution that is required. Sometimes you may need to have some trigonometric conversion. Okay, also let us see this condition. This is very important because this need to be understood, that is what we are finding, is it holding or covering all the conditions for, because you know that inverse trigonometric function, they only exist because of the restricted domains. Okay, restriction is there. Okay, you cannot, because they are not 1 1 and on 2. Okay, so just to make them 1 1 and on 2, you have to restrict their domains. Okay, so this is the condition that why we need to verify whether it is holding or not. So let us go for it. Minus x is lying between minus 1 and 1. Okay, so what is your x? X is again your tan theta. So here I get tan inverse minus 1, tan inverse 1. So it is minus tan inverse 1, tan inverse 1. Okay, so when it is at minus pi by 4. It is at pi by 4. Okay, now my question is again like this. So again I'll just multiply with 2, then it is say minus pi by 2 and it is your pi by 2. Now again I need to make it minus 2 theta, so I'll multiply with negative sign. But remember that thing. Okay, what will happen? The direction of inequality will change. It is going to change. Now it is your, see, I have to just add pi by 2 also. So it will become pi by 2 plus pi by 2 greater than pi by 2 minus 2 theta greater than pi by 2 minus pi by 2. So this turns out to be pi. It is pi by 2 minus 2 theta and it is your 0. Okay, so 0 less than pi by 2 minus 2 theta, and this is pi. So if you remember, from 0 to pi, this inverse trigonometric function will hold well. Okay, so there is no problem in its existence. Okay, now question number 14. Question number 14 is your differentiate y is equal to sine inverse 2x root 1 minus x square. X is lying between minus 1 by root 2 and 1 by root 2. So let us see this question. Okay, what should be the substitution? I should get something sine from here. Now let us see let us work out what should I get from here. If I put say x as sine theta, it will be 2 sine theta and 1 minus sine square theta will be cos theta, and it will definitely be your sine to theta. Okay, and sine to theta will fetch me the result. Okay, so or I can just put x as cos theta also. Okay, but I just you should work out. There is a very important example in your inverse trigonometric function. If you see that in your inverse trigonometric functions, and there is one example where you were supposed to put x as sine theta or cos theta, depending upon your line between the quadrants. Okay, so for this condition, if you I would suggest you to go for example number 3 of at page number 45. Okay, in which we did that sine inverse 2x root 1 minus x square, this is equal to 2 sine inverse x for x lying between minus 1 by root 2 and 1 by root 2. Okay, this was the example. And second one was same thing, 1 minus x square is equal to, it was 2 cos inverse x for 1 by root 2 and between 1. If you remember, these examples are done. Okay, so they depend upon these conditions which are there, and that what substitutions should be there. Okay, for the very first case you were supposed to put x as sine theta, and for the second case you were supposed to put x as cos theta. Okay, so here what I need to do is I'll put x as sine theta. This thing implies theta is sine inverse x. This thing implies y is equal to sine inverse 2 sine theta, and you know it will be 1 minus sine square theta. So this is sine inverse 2 sine theta cos theta, and it is your sine inverse, say it is sine 2 theta. Okay, so it will be your 2 theta, that is equal to 2 sine inverse x. Okay, 2 sine inverse x. So let us check the derivative. Now dy by dx, this is equal to 2 times d dx of sine inverse x, and the derivative of, you know what is the derivative of sine inverse x is 1 upon root 1 minus x square. So it will be your 2 times 1 upon root 1 minus x square. Okay, so this is the derivative. Now let us see this condition alongside which is given, how to verify it. X is lying between minus 1 by root 2 to root. What is your x? X is your sine theta, 1 by root 2. Okay, so theta will be your sine inverse minus 1 by root 2. Here it is sine inverse 1 by root 2. So you know it is minus sine inverse 1 by root 2, and it is sine inverse 1 by root 2. Okay, and you know this is your minus pi by 4, and it is your pi by 4. Now come here, we just were having 2 theta, so 2 theta will be between minus pi by 2 to pi by 2, and you know that inverse function is properly existing, so there is no problem in existence. That is why this is defined for this particular values. Okay, and the last question we are going to take is your question number 15, and this your question number 15 says y is equal to secant inverse 1 upon 2x square minus 1, where x is lying between 0 and 1 by root 2. Okay, now let us see what to put. Okay, you know I need a secant out there. Okay, a secant out there. So if you remember, see 2 cos square theta minus 1. 2 cos square theta minus 1 is the formula for cos 2 theta, and 1 upon cos 2 theta is secant 2 theta. Got it? So what should I put? X as, if it would have been 1 minus 2x square, then I would put x as sine theta, because 1 minus 2 sine square theta is cos 2 theta. So here put x as cos theta. So theta is cos inverse x. So what will I get? Secant inverse 1 upon 2 cos square theta minus 1. So what is your 2 cos square theta minus 1 is your cos 2 theta. So I'll get it as secant inverse cos 2 theta, okay, 1 upon cos 2 theta. So it becomes secant inverse secant 2 theta, and I'll get it as 2 theta, okay, which is your 2 cos inverse x. So let us differentiate with respect to x. I'll get it as dy by dx is as 2 times, what is ddx of cos inverse x? It is minus times 1 upon under root 1 minus x square. So it is minus 2 upon 1 minus x square. Okay. So that is ddx of cos inverse x is minus times 1 minus x square. Okay. Now let us